Hello again, programming languages students, and welcome to another Prolog video. So we're nearing the end of our Prolog series here, and so the last big detail to track in here is pruning or cutting, or often what's called is basically stopping backtracking. And so in Prolog, there's a symbol exclamation point, which is called a cut, and it always succeeds, but it never allows you to backtrack. So we want to prune the decision tree. So the reason we want to do this is the examples I've shown you where we've occasionally seen a true result and then it waits and searches and then finds a false result. This can sometimes cause problems in functionality when you have multiple predicates that call other predicates. Um, and ideally to run correctly, you'd want to get just a true value and then stop. So you want anything that's true and then stop hunting and looking for all other true values. Um, And so it's important to include good backtracking in some predicates. Sometimes you need it, sometimes you don't. If you're able to get just a result and not have it continue to hunt have it continue to hunt and then find a false, um, then you don't necessarily need an exclamation point. You don't need to cut backtracking, um, but in some cases you do. So we're going to follow some slides on this example, and then I'll do one more video where I do a live example and programming example where I do factorial and talk about how exclamation point is very helpful there. So um, we're going to go back to our jealous example and we're going to talk about cut. So if you remember all the way back to our earlier video, we had our little almost love triangle where Vincent loves Mia, Marcellus loves Mia. We don't know who Mia loves, but we defined this jealous thing. So A is jealous of B if A loves C and B loves C. And you'll remember that when we did this, Vincent's jealous of himself, Vincent's jealous of Marcellus, Marcellus is jealous of Vincent, and Marcellus is jealous of himself. So we have 4 different results here. And what we want to do is trim that list down. So the way we're going to write this is we have the old predicate we were working with, jealous AB, loves AC, and loves BC, but we're going to put an exclamation point in between. So let's see what this results in. So we look at our decision tree. We try jealous XY. It matches with our predicate here, jealous. So X is unified with A, Y is unified with B. And then we go into our check. Is this possible? So loves AC. So the first thing we check is Vincent and Mia. And so if A loves C, this is potentially plausible with Vincent and Mia. Then we're going to pass our cut, which always succeeds. So we just go ahead and check loves B and C. Well, C is Mia, so we look for who else loves B. And in this case, Vincent is our answer. So Vincent loves Mia and Vincent loves Mia means that X and Y can both be Vincent, so he is jealous of himself. And while we're still down here on this part of the tree, we can check another B, C, Marcellus and Mia. And so now Vincent is jealous of Marcellus. And this is the part where we would backtrack up. So we found all the combinations of with A, Vincent, and C, Mia. We found all the different combinations of B and C that work. And so normally what we do is backtrack back up, try a different A and C, in this case Marcellus and Mia, and then find out that Marcellus is jealous of Vincent and Marcellus is jealous of himself. But to get back up there, we have to go back through this loop to go try a different A and C. We've already been down this path, so now we're trying to go back up and go to the other path, but this exclamation point is like a little barrier there. And so we can't backtrack. So that's the basic operation. Sorry about the extra flip there. That's the basic operation of backtracking. So this allows you to trim your tree and only have specific results. And if you write it correctly, there's ways to really limit and trim a lot of predicates that would otherwise be pretty unwieldy. So we're going to show I'm going to show you a live programming example of factorial and how this can really make a big difference if you do good backtracking. So I'll talk to you next time.